Alright, champions, we're over here with the existing valves as rattly as they are on the valve tester. Sitting around an average of about 60% plate dissipation, and they've been stable despite their rattly behaviour. And the measurements drawn with texture on the top there, actually not too far off in terms of their relative plate currents. So let's see how they go, see if there's any microphonics, but we might reuse them for now. So it's up and sounding good. Just checking a few voltages, and I found massive imbalance there on the screen node stacked caps. You know, they should be in series, so sharing the same voltage. 6.4 volts DC across the bottom one, so the one that goes to ground. And pretty much almost the full plate voltage, well, screen voltage across the top one. So, is that a shorted cap, or is that a open resistor, or both? I'm testing this at a reduced voltage, so that top one is 500 volts, and it's only getting 429, so we wouldn't have damaged the cap. But I don't know how long it's been like that, so now we've got to remove those resistors and test those caps to see if one of them needs replacing. The bottom one is a bit suspect. And test those resistors. The top one may have been over dissipating, so we may have to replace that just for longevity's sake. It's a bit silly having 56k ones in there. 220, 470k is adequate. It's just a bit of a waste of energy and unnecessary heat being generated in that front area. But I guarantee there'll be people swearing black and blue that it sounds the way it does because of that resistor that's just there to balance the voltage across the two caps and to bleed them when the power's switched off. Alright, so I've just subbed in some 100k resistors there. We can see the problem still remains. So that's a shorted cap. What were we saying the other day about caps really going short? They usually go open. They do usually go open, but this one is short. It's not a hard short, but it's very low resistance instead of a capacitance. The reason I subbed some resistors in there is because the other one's tested passively okay, bang on 56k. But sometimes under high load, you know, thermal things happen and the resistor either opens or goes high. Whereas their brand new V-Shay 3 watt metal film 100k, and yeah, it's definitely the bottom cap in the totem pole at fault. Yay! So we've got to order parts and wait and do more work. I've already probably spent double the amount of time on this that I quoted for, as per usual. Every layer of the onion you take off is just another layer of mold. So that issue with the caps, there was a bad cap, but it wasn't the one I was thinking it was. So I've got a new one in there now, and we can see we've got about 233, and we've got about 233. So we're nicely balanced now. I've just replaced those silly 56Ks with some 100K, and we're nicely balanced. So I guess, thinking about it off the top of my head, napkin sketch, I guess the failed one was the top one where most of the voltage was dropping because it would have had a massive equivalent series resistance, ESR. So therefore most of the voltage was dropping across it, and the bottom one in the totem pole was fine. I've got a feeling maybe that clamp was done up a bit too tight on it, and that might have caused some internal pressures to cause it to fail prematurely. Because asking around with my colleagues, I did reach out to several, and none of them have seen a F&T go bad in that manner, particularly one as young as that one. So we've got the exact same cap in there. It's still available, that exact type, from my local supplier. I put a new one in. Now we're perfectly balanced. And of course this little tester told me that it was perfectly okay, as did the multimeter. So it goes to show that a lot of the time with caps in particular, you can't really glean much from measurements without actually putting the thing in a use case scenario and then taking measurements, and that's when any weaknesses or any issues with it show up in terms of like ripple or excessive voltage drop in that case. I mean, this thing's cool, and I see other tube amp guys, valve amp guys on forums and whatever swinging around like a big flex, but this has told me that every single capacitor I've ever measured has been perfectly fine, even when they've got shit leaking out the plug and it's massive ripple. It always says, yeah, it's perfectly good, it's a great capacitor. So yeah, they're kind of pretty but useless. You can get some more professional ones, like HP and stuff do ESR and LCRs sometimes combined in the one unit, that do test at higher voltages and put the thing under the kind of strain that it would see in a circuit. But then they cost like $3 grand, so I think I'll be buying an Audio Precision before I get one of those units. But hey, if one pops up cheap, the thing with test gear is if you're buying second hand, you kind of need to have test gear to test the test gear. So without it being calibrated, which often costs more than the unit itself, you can't really trust it. Alright, so we've got her up and running, sitting at around 50% bias, and it's been up at that level for about 3 or 4 hours with no movement at all. So those, I'm pretty satisfied those output valves are stable, with a bit of movement and tapping in that area. There's no fluctuations, so we know that the valve sockets are in good condition and the valves are viable, despite being slightly, well, not so much microphonic, but just physically rattly. Sometimes that manifests itself as microphonics on the output stage. Other times it doesn't. In this case, it doesn't. So now I'm satisfied that's stable. I'll just remove those meters temporarily. I'll take some measurements afterwards for the invoice, but I'll just show you in detail what we've done, and then we'll do some sound samples. You know, champions, the usual sort of affair. Just realised one of those leads was wrapped around one of the EL34s, and that is why we go for silicon test leads, champions. Otherwise they would have melted themselves to the valves. Alright, champions, I'll just find my little blue poker and we'll go over what we did. So the obvious thing is we've reverted the architecture back to pretty much a 2204. We've removed the effects loop at the customer's request, and we've used these little nickel fold over plugs there. They just look like a button from the other side to suit the 3/8 holes, and just a little rubber grommet there where the bypass switch used to be. You can see all the scratches there from the previous guy trying to deburr. There goes the IQ level again as soon as you hit record. Trying to deburr his hole there. He could have just used a countersink or a larger drill, but anyway. So the very first thing your signal sees there on the high gain side is V1A. We've restored its functionality again, and we've got some coax running to that. We've gone back to the stock resistor there and a film 0.68 microfarad for the bypassing, and the 2.7 K replacing the 10K on the cold clipper, which gives you a bit more saturation there. Replacing those, what were they, 220K or the 220K in its snubber there. We've got a pair of GO carbon film, half watt, 100Ks. These are the same ones I use on my Marshall FYM boards. We've gone with a Wiha there for the coupler. Now, various people commented on the previous video. 2.2 nano is actually the value of the like the 1959, the super lead. I had my brain in 2203, 2204 mode, so I was blind to that. But apparently, in talking to Jace as well, look, I'm not the encyclopedia of mods. That's more like Jace and Alex and some of the other blokes I'm in cahoots with. Jace did inform me that changing that to a 2.2 nano is a common thing to tighten up the bottom end, and when you've combined that with, which I'll show you shortly, the depth mod or a resonance control, it can clean things up a bit. So what I'm going to do with this one, I think I mentioned in a previous video, I've talked to the customer and he wants to take it home and warm to it with his rig. Now, he doesn't have a super complex rig, but he just wants to test it with his guitars, his cabinet, in his room, with his recording techniques and whatever, and we can revoice it from there. And he was pretty keen to get it back and actually have some time with it rather than just try it in the shop. Sometimes I'll do some final voicing in the shop. I'll just tell the customer, look, set an hour aside and I can give it a few tweaks, things like bright cap values, stuff like that, before you go. But he's happy to take it with him and have a good play, get to know it, and then take some notes, and if anything needs changing, bring it back and we'll sort it out. Which I agree with. I think that's a good way of doing it, testing it with your gear, your speakers, your guitar, your pedals if you use them, and in your room that you like to play in if it is a home recording amp. So we reverted basically everything back to the initial architecture. Where I've needed some ceramics, I've gone with the Vishay ceramides, which are my favourite. They're my favourite from a microphonics and stability point of view, but they're also my favourite because they've got a really long lead. So they're perfect for this situation where the resistor lead wouldn't be long enough to make this distance. I do like to have the components close to one of the ends, not floating around in the middle, and then just run one of the leads to the input of that pot there. Now we've got a 470 pico bright cap there on the gain. That was a little bit peaky on my Strat at lower gain settings. It was okay through the low sensitivity input, but it was a little bit over the top for the high sensitivity with a single coil Strat. So what I might offer is, I can't remember if he said he's got a lot of humbucker or single coil style guitars. I think he said he's like a Les Paul man. So it may be perfect for that. But I did suggest to him what we could do is change this with a pull pot, and you know, whichever mode you use the most will be the pot pushed in. And then if you say you want to disable the bright cap for a Strat, but you mainly use Les Pauls, you'd make it so when you pull it, you disable that, or take it out of circuit, or possibly change its value. The world's your oyster, champions. You can do all these things. You got so much room for activities in this amp, as the Step Brothers would say. So I redid a bunch of wiring, as you saw in the previous one. One of these pots, you know, the shaft pulled out of it when I was trying as gently as possible to remove the knob. And a few people commented about left-hand drill bits, which, yeah, if I had a half a brain, I would have used. However, all the pots were glued on, so there was like an araldite epoxy inside them. So once that gets in the grub screw, I'd say it's kind of, without maybe adding some heat or something, but you can't get in there. It's sort of all bets are off. But we've removed the wire off the back of the pots, which I'm not a big fan of, and we've completely changed the grounding scheme, but we'll get to that shortly. We've gone back to 22 nano phase inverter coupling caps, and everything's stock in the phase inverter at the moment. We've replaced those big 350 volt 10 microfarads with some more sanely proportioned V-shays there, 100 volt 10 microfarad axials. They're not too expensive. They're like, I don't know, $3 or $4 each, so they're not as cheap as radials, but for a couple of bucks you've got the right form factor there, and you don't want to be skimping in this area. If you're gonna do any work carefully in this thing, make sure it's the bias supply. Alright, so we've redone everything in this area. Again, we've changed the ground scheme, which we'll get into shortly. I've already said that, broken record. But just cleaned up all the wiring. I replaced those link wires between the two series caps there, and like we said, we had the problem with one of those, the top one of those capacitors going massively high ESR. So that made it drop pretty much 90% of the voltage, 95% of the voltage, and the other one was only getting 5-6 volts across it. So although they are 500 volt caps, it wasn't overrated, but yeah, that cap had failed. So replacing that cap, now we've gone back to the balanced voltage between the two, which is what we want. I've replaced those resistors, the 56K on top, because it was dropping so much voltage, had evidence of overheating. There's no need to have a 56K there. It doesn't do anything tonality wise. It just gets unnecessarily hot. So I've just gone up to 100K. You could go 220 or 470 there without any issues. Where we've got a ground connection, I've removed it from the capacitor mounting hardware. I like to have all the grounding points independent of any hardware, just so there's no stress on the joint. You just want its job to be electrical, not mechanical. Not mechanical. Now I've got heater balance resistors down there. We've removed the center tap of the heater. Someone did ask why I like to do that. I think it was on a Fender video though, but basically in any amplifier where you've got a cathode follower, there is potential there for the high voltage which is on the cathode to leak to the heaters. Now if you've got a failed valve in the cathode follower position, it could end up being a hard short to the heater. That could cause all sorts of damage to the heater windings, but it could also cause damage to the wiring itself. If you did have a heater to HT short elsewhere, for example someone forcing a valve in the wrong orientation, these will fuse, so go open circuit, instead of your heater center tap delivering as much current as possible from that HT to the heater circuit. So it's just a level of safety essentially, and the other reason is sometimes the heater windings aren't perfectly balanced, so you do end up with voltages being a bit off, and that results in just noise. So ideally we want to elevate these, but I have tried it out and the noise levels are negligible. It does depend on each power transformer, is a little bit different. You've probably seen the Vox AC30TBX, I think it was, where I actually had to put imbalanced resistors on in order to compensate for the unbalance in the heater windings. So I tested that with a humdinger pot, temporarily installed like a 100 ohm pot like you'd find in a, you know, a silver face fender. Measured those resistances where the hum was at the null point, at the least hummy, and then installed those resistor values as close as we could with the E12 series. However, I don't think we've got to worry about elevation in this case because it's remarkably quiet with a bit of shielding on there. The LED video lights like to emit quite a bit of hash and noise, but when you stick a bit of valley over the input area, she was very quiet with everything maxed out. I think you'll agree. So I've done my usual Marshall stuff here. I've got 2.2Ks on the screen grids there. That just helps the modern production valves survive when you push them hard, particularly if you're using a attenuator. The screen grids are usually the first thing to go with the 1K resistors on there. And we've got flyback diodes on there, so if for whatever reason the speaker becomes disconnected from the transformer secondary, the output transformer secondary, they will cop the brunt of it and make sure there's no flyback event causing damage to your sockets, your valves, your transformers, your friggin' everything. So speaking of the speaker, we've got the original sockets, but I'll put some heavier bus wire there, which is a bit more mechanical support. We've run the output transformer secondary ground to one of the cathodes, which is fine, and we've got a new switch there. This is one of the shorter switches, which I think I described in a live stream recently and showed the number, but this is to replace the failed switch, well, the failed selector, which I don't like even when they're in good condition. Problem is they're a little bit larger and the holes are larger diameter, so getting them to fit together is a bit tricky when combined with the mains replacement as well. Now I have hardwired this, but for uniformality, is that a word? To look the same as that one, I've replaced the mains power selector as well. But if you do change that to anything, the amp will ignore you and it will just keep running on 240 volts. So if it accidentally gets moved or some kid plays with it or something, you won't blow your amp up. But if it ever did want to be shipped overseas or taken on a tour or whatever, you could just reconnect that wire to the appropriate tap and then she's switchable again. Now, I sort of worked off a center point for these and enlarged the holes outwards, knowing that these are pretty much going to be touching in the center. I'll show you from the rear panel shortly. And that just gave us enough clearance to the IEC as well. I did have to shave a tiny bit off the plastic on the new socket. Whoa, champions. The astute among you might have noticed those green and yellow wires are back to front. The green is supposed to be the 16 ohm and the yellow is supposed to be the 8 ohm. Just during testing I was getting some strange measurements there, so you know, not perfect. I fuck up just like everyone else, but that's why we do extensive testing before we ship everything out, so we catch everything before it gets back to the customer. So here's the two new switches. You've got your impedance one here. It's pretty tight against the voltage selector, and then the voltage selector is pretty tight against the mains. I must need breakfast. I'm forgetting how to speak. So we've managed to cover up most of the scratches and damage to the rear panel there as a result of these being a bit larger, and it looks the part now. And here's those little nickel plugs from the outside. They're nice and tight, no rattling there, which is good, and a little rubber grommet where the bypass switch used to be. Well, since it's male, I guess you call it a panel mounting plug. I don't know. The original one had these screw fittings which squashed the wire to the point where it either it wasn't tight enough and you could easily pull the mains wires out, or it was over tightened and then it tried to cut the wire. So on modern mains connections, there will be like a little flap of metal that goes in. When you tighten the screw, it tightens on that flap, and that flap squeezes the wire. But if you've got an actual screw threading straight onto the wire, it tries to cut it as you tighten it. So not ideal. So I went with a new one and hardwired that. We've got a new dedicated screw down here. Now, it may look like that is sharing the screw with the valve socket. However, I'll show you on the other side, but the valve retainers are mounted on the same screws as the valve socket itself. So that frees up these two screws over here that used to have the, you know, the Rastafarian hat or whatever. The fiberglass hats, I think, on the older ones. On this one, I think they went to a metal one, but they were missing on this amp. So I've just gone with bear claw style retainers, or bear trap, whatever you call them, and mounted them on the same screws as the valve sockets. And that means we've got two grounding points here for whatever we want, so we don't have to go drilling the chassis. In this case, I've used this one here because it's closest to the IEC. It's a dedicated safety earth with nothing connected to it at all other than that. And I've gone with a stainless steel screw, a silver plated eyelet, toothed eyelet, then a flat washer, stainless, then a spring washer, stainless, then a stainless nylock nut. And that's how I like to do, in particular, this connection, but all my grounds. And we've got our 2 new fuse holders there, nice and fresh, without the reamed out fuse holder on the other side. So pretty much this whole area has been redone. The only thing that we've reused is the 2 speaker jacks, which were fine. Just gave them a clean up, and the contacts were nice on them and not corroded. So back in they went. Now all the grid stoppers, or 2 of them I think, snapped off in my hand because they've been bent back and forward a few times. So I put some new Yagio carbon films in there, half watters, and just mounted them out of the way of the screen grids. So the screen grids have quite a bit of room around them for heat dissipation, and there's no chance of anything melting or touching it. The other thing was, from the factory, there was very bad tack soldering on these connections, whereas I've actually wrapped the resistor lead around the original wire and gave it a clean with some alcohol just to make sure it actually wetted. But that solder that I use wets to everything. It's fantastic stuff. Now you can see down there I've sealed off the rust with that penetrol, and that's really cleaned it up quite a bit. I did take to the chassis wherever there was a grounding point with a Dremel just to make sure that it's 100% clear, and made sure I got no penetrol on that area. As Lyle did mention in the comments, just be aware that the penetrol will be dissolved by isopropyl, so apply it after all your cleaning's been done, all your grease and schmoo's been removed. Now speaking of schmoo, I could not believe how much crap came out of this amp. I'm glad I went above and beyond though, because now it looks schmicko, nice and dry and clean as it should be. So other techs out there, please don't just spray the whole area of the panel to try and get the pots. Use a tube to deliver a tiny bit of lubricant right in the pot, because the amount of amps I get in here that just have this layer of grease spread throughout the whole chassis from cleaning stuff and just spraying random fluids inside. It's a bit disheartening. Down there we've got the blanking grommet there where the old valve used to be. Keeps the fingies out. Now let's go over the ground scheme champions. I'll put a link to Lyle's video down below, which is a fantastic explanation of a way to improve the Marshall ground schemes. I think he showed it on a 1959, but same principles apply. And he explains it way better than I could, because he has he's just got away with words, champions. I think we know that now. Alright, starting from the reservoir capacitor. So these are, well, essentially, I guess you could call it voltage doubler. You've got a ground point right here, short as possible, with an 18 gauge solid core wire to the ground there. We're also using that grounding point as the ground for the rectifiers, so you can think of that as the dirtiest ground in the whole amp, right where your mum hangs out. I'll get one in every video if it kills me. The next one, so that's all that does. We've got a dedicated one for the safety ground, which is only connected to the IEC lead. Our next ground, which is a screen grid node, comes down here and is mounted the same point as the presence control, and the same point as, if we follow this wire up here, your phase inverter ground. So you think of that as still your output stage. Now the only other grounding point we've got is down the front end here, which I've drilled a hole. I know I don't like drilling holes in classic amps, but if it makes them perform better, I am quite partial to it. So anyway, every other ground in the amp is connected here. We've removed the ground wire off the back of the pots. So your ground from, your volumes and your tone stack and everything comes down here, as well as the cathodes for that those preamp stages, and that results in a remarkable improvement in the noise floor at this thing, particularly when it's at stupid settings, because almost anything's better than the stock setup. And hidden underneath there is the 2 preamp, well, the single cap, the 2-section cap, and its ground goes down to that point as well. Alright, so that's all the controls maxed out. Fair bit of noise, but put a bit of shielding on there. And that, for a 2203 with all the controls all the way up, that's remarkably quiet with that new ground scheme. So hats off to Lyle for documenting that so thoroughly on the video that I have put in the description below. Go and watch his stuff, champions, and in particular that video, it's great. But back in the day, these things were used for loud stages, rock and roll, you know, but there is a reputation on some of these amps that they're just noisy, but they don't have to be. They adhere to the same laws of physics as you and I, and if we can make it adhere better to them for our needs, nefarious purposes, we like to do that, don't we, champions? And on the top, we've cleared off the loose corrosion as best we can without fully scrubbing the thing. Kept the label on there. I don't think I went over this last time, but 25th of the 10th, 77, wow. So that's a view of the no longer used valve socket from above, and you've got your new belt and bear trap type retainers there with stainless screws. You can see the stainless screws down there that appear to be doing nothing, but they're the grounding points on the inside for various things. You can see the ones down there that weren't required. So let's get this thing hooked up to a cab and do some quick recording samples. I've got to get my chops up. It's hard to go from tech mode to player mode in 5 seconds flat. Just doing some sound testing, champions, through my cab down here. It's got a Veteran 30 at the top and an ET65 down the bottom, going into an SM57 in a closed back cabinet that I built. Nice little laser cut logo there. But I noticed some rattling in the left channel, and often that's just tools floating around on the bench or whatever. But looking a bit closer at my poor little speaker. Oh no. Time for a new driver. Look at it. You could probably glue it back, but yeah, once it's compromised, I'll just get a new driver. So that probably means the one on this side needs replacing as well. Bugger, there's always something broken, eh? When you fix shit, there's always something broken. Champions, I really need to fix this bloody pickup spring here. I should put a silicone rubber hose there instead of the spring, because it resonates like this. So yeah, nothing wrong with the amps, just me and my silly guitar. So there you have it, champions, another rebuild under the belt. Thanks for joining us on this epic journey. We've got some more epic journeys coming, I'll tell you what. It's never ending. So keep an eye on the channel. I'll release when I can, but you know, there's a lot going on. So bear with me if it's a little bit sporadic. Until then, legends, drink some water, moisturize your face. Moisturize your face and your elbows. Do it for me. Be good to your mother or someone else's mother. And the finishing touch, champions. We've got our little dress screws there with the cup washers in stainless steel to replace the wafer head screws. So until next time.